Hi guys, welcome to Unit 7 and this will be day 1. We're going to learn how to graph trig functions and the midline today. So one thing we're going to have to start with is that just like in other times in math you've converted from feet to meters, centimeters to inches, and you've done some conversions, we have a different kind of measurement that does the trig graphing. So in the prior examples where we did trig on the unit circle, we used mainly degrees. And degrees corresponds with a measurement called radians. Okay, they're convertible between each other, and we'll get to that in a minute. But trig graphing is mainly done in those what's called radians, and the radians use pi, and it's a unit of measurement for the angles. Okay, a radian is just another way to measure angles, just like centimeters versus inches. The most important thing we know is that 180 degrees equals pi radians. Okay, so when we went around the unit circle from 0 degrees, okay, and we went over here to 180 degrees, well, 180 degrees converts to pi. Sorry, I bumped that, okay? 180 degrees converts to pi, and that's halfway around the unit circle. So if I carry on and go all the way, that would be 360 degrees to go all the way around, and that would be 2 pi, okay? But the most important measurement is this 180 degrees equals 1 pi radians, okay? We're going to be graphing just sine and cosine today in radians, and I'll show you what that looks like in degrees as well. I'm sorry this is jiggly today. I'll try to keep it on the down low. Okay, so we're going to consider the first function here. So here's what I want you to plot. We're going to do the sine, okay? So this would be sine of the graph laid out for the sine of any angle x, okay? Well, the sine graph starts at the origin, or 0, 0. This is my x-axis, and this is my y-axis up and down. And go ahead and make these changes to the x-axis. It's hard to read on the handout. This says pi over 2 like a fraction. This is just pi. This is 3 pi over 2, and this is 2 pi. I know this sounds funny to put those measurements on there, but that's what they are, okay? So making that, what do they really mean? Well, if I said pi equals 180 degrees, right? 180 degrees goes there. And like in up above, if I go 2 pi, that's 180 times 2, all the way to 2 pi would be 360 degrees, okay? And in between that, halfway from 0 to 180 is 90, and halfway from 180 to 360 is 270. So you could think of like one of them as inches and the other one as centimeters. They're convertible between each other, okay? All right, so what does the graph of sine look like? I'm gonna go ahead and change color. All right, so the graph of sine starts at the origin, or 0, 0. And then the first point I plot is up one over here. Back to the x-axis here. Go another place, and it's gonna be in the middle of my labels there. And then it's going to come back up to here. All right, now we're going to not use straight lines. We're going to kind of curve those things out. You want to use a nice wavy line and get a swooping thing like that, okay? And our y-axis would be labeled, this would be a positive one there and a minus one there. So that is what the graph of sine of x looks like. It starts at the origin, and it goes up to a high point, it comes back down to the x-axis, it dips below, and then back up. And this is what's called a sine wave, okay? The graphs we're doing now are waves. They're not rigid and pointy like you've done in the past. So that's what the sine graph looks like. Let's do the cosine graph next, okay? So we're going to do a cosine graph on this next grid. So this will be the cosine. Let's update those axis labels. So this one's pi over 2, pi, 3 pi over 2, and 2 pi. Those axis labels, those are the radians. They'll convert to degrees. The first one will be 90. The next one will be 180. The next one is 270. And the last one is 360. So we have that all labeled. All right, so the cosine graph is a little different. The other thing I label is the y-axis. It goes up to 1 and down to -1. All right, the cosine graph starts at its high point. Okay, the next click will be on the x-axis, then it'll dip below, then it'll go up to the x-axis again, and it'll go here. Okay, we're not going to graph it like a V. We're going to kind of give it a curvy, swooping graph. Okay, and it looks kind of like that. It's curvy. So that's what the cosine wave graph looks like. And a lot of people think about the C in cosine, reminds them that this is kind of a C shape or a cup shape, or the cosine cup. Okay, so these graphs are called waves. Okay, if the graph continued, that pattern would just continue in either direction, and it would just be a wavy graph. All right, let's see what that looks like on the table. All right, so when you see pi in the labels, these are your radian labels. Okay, and they convert to the degrees labels over here. So 0 is 0 for both. All right, so we're going to fill out this table. So we're looking at the sine curve. What is the y value of sine when the x value is 0? We're looking at the graph. So when sine is 0, the y value is also 0. Okay. At 90 degrees, or pi over 2, that's our first hit here, the y value is 1. It goes up. The next part is, what is the value at 180, or in radians pi? So that's this part of the graph right here, and that value is 0. The next part of the graph, at 270 degrees, or 3 pi over 2, that's this part, the y value is -1. And the last one, at 2 pi, it goes back up to 0. All right, let's do the same for our cosine graph. So the cosine graph at x equals 0 is at 1, because it's up there. At 90 degrees, or pi over 2, that's this label, and that's the y value is 0 there. At the next point, 180 degrees, or pi, it dips below down to -1. Then at the next value, it goes up to the x-axis again, and the y value is 0. And then it goes above again, and the y value is 1 when we get to 360 or 2 pi. All right, so that is the basic graph of sine and cosine. Let's talk about stating the equation for the midline of each graph, and there's a little hint over here. A midline is the horizontal center line, y equals a number about which the function moves above and below. Now midline, you can kind of think about the word middle. Where is the middle of the graph from top to bottom? It would be halfway between the top of the graph and the bottom of the graph. Let's go back up to our graphs and look at what the midlines are, okay? So how would I find the midline of this sine graph? Well, first thing I need to do is locate a maximum value. You may have heard the word maximum before. Maximum is the highest point of the graph, and the minimum, there would be a minimum value right here, which is the lowest point of the graph. When I find the maximum and the minimum, I kind of draw lines to enclose the graph. Okay, I enclose the graph from top to bottom. So when this graph continues, it's going to stay that same thickness from top to bottom. What is the midline? It's halfway between. So here's what we do. Going from top to bottom, I count 1, 2. So my midline is halfway. 2 divided by 2 is 1. So my midline on this graph is y equals, and the y value for this whole midline, this dotted line here, is 0. So y equals 0 is the midline. Okay? So the midline on that graph is this center line here, the center line from top to bottom. All right, so down here, for y equals sine x graph, the midline is y equals 0. Let's go do the same thing for our cosine graph. So remember, we're going to locate a maximum and a minimum. It looks like there are 2 maximum values here. So the upper part of the graph goes here, and the lower bound of the graph goes there. So the whole graph stays between those lines, and that's 1, 2 units in between the top and the bottom yellow lines, and half of 2 is 1, and this would be the midline or center line of that. And that is also on the x-axis, so it has a y value of 0. So that's the midline. Okay? All right, so let's write that down here. So y equals cosine x of the graph above. The midline was y equals 0 also. Now, we're going to change things now. These are the basic graphs, but they can be transformed. They can move up and down, and it can be stretched and shrunk and things like that. So let's do some more examples when the graph gets a little bit different, okay? So, in the next page, adjust my camera. I'm so sorry. I've got a little bouncy. I've got a homemade little camera holder here, and it's a little bouncy. So here's the first one on the next page, and this first example. So like we did the last time, we're gonna draw a line at the upper or with the maximums of the graph. Okay, the maximum up here, right? That looks like the maximum of the graph, and this line here hits the minimums of the graph. So the whole graph stays between those two lines. The midline is we're going to count squares between. So this has 1, 2, 3, 4, or excuse me, 1, 2. So this is our midline right here. Okay? And what is the equation of that midline? So we go up and down. What is this value here? This value here, now this is labeled 1, 2, 3. So the y value is 3 there, so our midline is y equals 3. Okay, let's do another. This one right here. So we're going to enclose the graph in top and bottom. So there's the top bound. Here's the bottom bound. Let's do the dotted line. So I'm going to count from the top to the bottom. 1, 2, 3, 4. So half of 4 is 2, and the midline would go 2 units above the bottom and 2 units below the top. That's our midline. What is the y value of that line? Let's look at our scale. So that would be -1, because it'd go -1, 2, 3, 4, 5. So our midline here is y equals -1. Okay, the middle of the graph from top to bottom. The next one. There's my maximums, and here's my minimums. And count the spots in between. 1, 2, 3, 4. So let's go halfway. Half of 4 is 2. 1, 2. So that would go right here. Now, what is the y value of that? This is my x-axis right here, so that would be up 1, 2 from the y-axis. And my midline equation would be y equals 2. All right. Another example here. So this is a pretty big wavy graph. There's the tops. There's the bottoms. Counting the squares in between would be 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. 1, 2, 3, 4. Okay, so that line, dotted line, is halfway between the top and the bottom, and it has a value of -2. Okay, where did I get the -2? This is my x-axis right there, and I went down 1, 2 units, so the y value at that point is -2. Okay, because -1 is right here, -3, and so on. All right, so pause the video now and do the last 2 examples. I'm going to go ahead and continue so that you can see the answers, and then you will do 10 of these on Delta Math for your homework. You don't have to send me any pictures this time, okay? So pause your video. I'm going to go ahead and continue with these so you can check your answers when you're done. Okay, you should have finished these on your own. I'm going to go ahead and do this. So there's the top line, there's the bottom line, and halfway between that is here, and my x-axis is way down here, so that's 1, 2, 3. So this y value is 3 there, and my midline is y equals 3. And the last one, here's my top line, here's my bottom line, and my midline would go 1, 2, 3, 4, 5, 6. Half of 6 is 3. 1, 2, 3. So my midline is right here. And that equation would be y equals -1 for that midline. All right, I hope you got those right. So don't forget to go to do 10 quick problems on Delta Math, and that'll be it for today. Thank you.